Everything we do, every thought we've ever had, is produced by the human brain. But exactly how it operates remains one of the biggest unsolved mysteries. And it seems, the more we probe its inner workings, the more surprises we find. Welcome to Las Vegas, the entertainment capital of the world. I'm not here to get rich quick.
Neil deGrasse Tyson, right this way.
I've come to be tricked by some of the best magicians on earth.
Now, in order to catch fish, you have to have the proper fishing pole, and you have to have the proper bait. The Fig Newton.
With just a Fig Newton as bait, Mac King takes me fishing.
You and I are fishing out here in midair, but we're not looking for just any fish. We're catching goldfish.
Suddenly, a flicker of orange appears on our hook.
Neil, hold that glass over here. Check him out.
And voila! We've caught a goldfish.
That's a dang real fish.
It's real. It's real.
Magic is a sophisticated art form practiced by seasoned professionals
Rule here in Las Vegas.
who know exactly how to trick your brain.
Whatever you catch, you gotta eat.
Oh.
No, he's still there. He's still there.
So can the age-old art of magic shed light on how the brain works? With more than 100 billion nerve cells, each making thousands of intricate connections, the human brain, a lump of tissue small enough to hold in your palm, is so powerful it can contemplate the vastness of the universe. Yet, it can be fooled by the simplest coin trick. Meet Apollo Robbins. Stage name, Apollo the Gentleman Thief. A few years back, he embarrassed President Jimmy Carter's Secret Service agents when he picked their pockets during a visit to Las Vegas. Today, Apollo has agreed to share some of his secrets with me. First, he shows me a special motion he uses to distract his victims when he's picking their pockets.
So when I go for a pocket, and I'm coming out of it like this, that motion, done in natural time, will draw the eye a little
I'm going to follow that hand out of my pocket.
Yes.
Even if that's just a decoy for me.
And I have a second longer with this hand to do something else.
According to Apollo, it's this curved motion that diverts my attention from what he's really doing, stealing something from my pocket, or making a coin disappear. Neuroscientists Susana Martinez-Conde and Stephen Macknick have come to watch Apollo. They're hoping he can help them solve a fundamental mystery. How does the brain decide what to pay attention to?
Neuroscientists know a lot about how the brain works. We know where the visual centers are, we know where the auditory centers are, but we don't really have a very good idea about attention and awareness yet.
They decide to video Apollo using his curved motion to make a coin disappear. Back in their lab, they prepare test subjects to watch it. They fit them with this contraption, equipped with tiny cameras aimed at their subjects' eyes.
We're measuring the eye position 500 or 1,000 times a second, and what we're analyzing is where are the eyes at every given moment of time in comparison to what's being presented on the screen.
The experiment reveals their eyes follow the path of Apollo's hand, just as he predicted.
I'm going to move my index finger from left to right, and I'm going to follow it with my eyes. What my eyes are doing right now is smooth pursuit. A smooth pursuit allows you to track a moving target.
Vision is a coordinated effort between the eyes and the brain. When our eyes see an object, the light from its surface travels to the retina, where it's transformed into neural signals. These signals go to a part of the brain dedicated to vision. Here, we start to form an image. But we don't pay attention to everything we look at. How does the brain control what we focus on and what we don't? In a new study, Susana and Stephen, working with Jose Manuel Alonso, found that when our eyes track something, like Apollo's curved motion, there's more than one type of brain cell at work. One type of cell detects motion, while the other suppresses the background.
Your brain is actively suppressing the parts of the visual scene that you don't pay attention to.
And this relates to what Apollo was telling us, that when you're tracking something, that you ignore everything around it.
These two types of neurons that we are beginning to understand could explain, why magicians are so good at what they do.
In another trick, I think I see a coin flying through the air, but it never lands.
That was good.
Yeah. So you see the coin, the shininess flicking through the air. You see the light glint off.
I see it.
Yeah. And then it disappears.
Yeah, and I saw it go over.
And you saw it go over.
I swear I saw it go over.
And it doesn't go over.
I'm sure I saw Mac toss the coin. Why did I see something that didn't actually happen? Back at the lab, when volunteers watch the trick on a monitor, they're stumped just as I am.
So Mac's creating this illusion of inferred motion. So you see this motion that didn't actually take place.
Turns out our brain is sensitive, maybe too sensitive to motion. It's a survival mechanism.
That motion detection, that's really a useful brain skill.
The fact that I detect motion even though it's not actually there.
Yeah, you make these assumptions to ensure, that you don't get hit by a spear coming from your left side.
It's better to think there's a tiger moving in the brush and be wrong than to not notice it and get eaten.
Yeah, exactly.
Sometimes even the most astute magicians, like the world-renowned Penn and Teller, aren't sure why a trick works. Penn and Teller have been performing magic tricks for more than 25 years. Penn is the boisterous talker. Teller, his silent partner.
A standard version of
This time, it's the magicians who are asking the neuroscientists to explain a trick.
cups and use
It's one of their favorites, where they make balls appear and disappear under plastic cups.
take the ball, we place it in our hand, we vanish it, and it appears underneath the cup. Here's a little variation Teller came up with, where he takes the ball, places it in his hand, and shows you underneath the cup, yet it still appears underneath the cup. If we do that center ball, place it visibly in the center cup. These side balls, really put them away, we don't need them anymore. We have three balls right underneath here. That's where they regroup. We have a giant ball in the center cup, one more giant ball on either side, and of course for the finish, it's an American baseball right there.
My head is still spinning. Amazingly, the trick works even when they do it with clear plastic cups.
This is the Penn and Teller easy-to-follow version of the cups and balls.
Teller has asked Susanna and Stephen to explain one part of the trick.
And show it.
He's so curious, he's agreed to give an interview, provided we don't actually show him speaking.
The thing that I'd like to see Susanna and Steve study is that very elemental move where the ball's on top of a cup and I tip it off while secretly loading the ball.
Teller wants to know why we don't see him sneaking a second ball underneath that cup. To him, it's obvious. The neuroscientists record him performing this move and show it to their volunteers. Then they show a different version, one that blocks Teller's face. That turns out to make a real difference. Like the curved hand motion in a coin trick, the magician's face commands your attention just enough to distract you from what's really going on.
Even though you may think that you're looking at the balls all the time, the fact that Teller's face is present can draw your attention away from the loaded balls in the cups.
Magic is sort of cognitive juggling.
The center ball, the center cup, each of the side balls really come.
If you come to a magic show with the intention of exercising your ability to discern fact from fancy and you fail, that's a fine piece of entertainment. So it's this wonderful playground where you can sort of relax and go, oh boy, it's really hard to understand the world.
looking for the skyline.
That's in the 20s. That's...
Careful.
If you're heading this over here.
Excuse me? It's a road. Oh, I'm sorry. 43rd